One, geometric probability. We are going to consider the probability scenarios when we're talking about, shapes and landing in a certain square. You can combine what you know about areas of geometric figures and probability to analyze a real-world problem. A class is hosting a dart competition to raise money. 3 different designs are under consideration. All of the dartboards are squares that measure 50 centimeters by 50 centimeters and have different sections for scoring. So all of these outside shapes are a square of 50 centimeters on a side. The bullseye, the big bullseye, is just the one circle. The 4 circles in this 4-circle shape, they're all the same size. And then last of all, tricky triangles, there's 1, 2, 3, 4, 5, 6 congruent triangles. So it might be a little bit unconvinced, but we need to be considerate about it. The edge of this triangle is the same as the edge of any of the triangles. And they're all actually isosceles right triangles. So these 2 edges are the same, which means these 2 edges are the same. And now with the idea of the side of the square being 50 centimeters on a side, we can start to get an idea of how long each of these sides of the triangles are. So what do you think? Which dartboard will give you or the player the greatest chance of hitting the scoring section? And I would rephrase that as which dartboard would give the player a chance. I guess I don't want to rephrase that. I like the way that I said. I was thinking differently about it when I first wrote my notes. I think the player has the greatest chance of hitting the scoring section in the big bullseye. Biggest circle, biggest spot for us to land. So I think the big bullseye will give us the best chance, or give the player the best chance of throwing the dart and landing in a scoring section, because there's just more area. Because there's more area of bullseye to the part of the square that's not bullseye. Okay, and so if you land in the bullseye section, you win. If you don't, you lose, and whatever else happens. Or you score a certain amount of points. Okay, Devin says that the number of desired outcomes for big bullseye is 1, because there is 1 scoring section. This means that 4 circles have 4 scoring desired outcomes, and tricky triangles have 6 desired outcomes. Is Devin right? No. Go back and look at what an outcome is. No, Devin is incorrect. The thing is, outcomes are not based upon like how many of that thing there are. They're based upon whether or not something happens or doesn't, or a third option. But in this case, there's only 2 outcomes for each dartboard, landing in the scoring section or not. So therefore, all 3 dartboards have the same number of outcomes. Okay, a question to consider. What should Devin consider rather than the number of shaded sections? Devin should consider the likelihood of something happening. What could happen? You could land in a scoring section or not, and therefore those are the outcomes. That has been page 895. Thank you for watching this video. In the next one, little sneak peek, we're going to talk about the mathematics of getting in the probability of scoring. And so this is where our conversation from these 3 pictures is going to require us to know area and make some calculations, and then use those calculations to get to a probability. So thank you for watching. Like, comment, and subscribe, and I'll see you in the next episode.